Okay, now I allow people to do their own calculations with calculators because you can't really evaluate this function without a calculator. It's an appropriate use of the calculator. Okay, so what I asked was for the values of this function at t equals 12 and t equals 20. And people gave me the values. I got 4,300. Now, you know, this could be refined. You could get it down to the dollar, and you probably want to do that. You probably even want to get it down to cents to be sure you have enough precision. But for right now, it's about 4,300, and we have about 5466. So a trapezoidal graph, just based on the t equals 12 and t equals 20 points, would then look like this. Okay, so we'd have 4,300 here. We'd have 5466 here. And of course, the 4,300, everything would be a little more precise. We'd have 12 here, we'd have 20 here. And then we'd have this. So now we can very easily calculate the area of this graph. Okay? And what we're going to do with the problems that you're asked to do is we're going to compare the area of this graph to the change in this antiderivative function. Okay? Change in this antiderivative function as t changes from 12 to 20. So we would evaluate the antiderivative function for t equals 12, we would evaluate it for t equals 20, and then we'd do a subtraction to see how much it changed. And the result will be fairly close to the area of this trapezoid. There's profound meaning behind that. Now, in the next step, you're going to divide this interval from 12 to 20 into two parts. So you're going to go from 12 to 16 and 16 to 20. That's going to give you the two yellow trapezoids you see here. You're still going to have these values, and you're no longer going to have the first trapezoid. You're going to have this middle value, the 4828, and we can see that these trapezoids will lie a little bit below this one. Maybe not all that much below, and you're asked to estimate how much difference there is, but it's going to lie a little bit below. Then we can easily calculate these two areas, and of course we're going to add them up to get a total. So we'll have this area, we'll have this area, and in parentheses, well, we'll have this area in this parenthesis, and then the total of the two areas in this set of parentheses. And then we're going to compare that to the change in the antiderivative function between 12 and 20. Then I ask you to speculate on what would happen if you divided this one more time, so that you would get from 12 to 20, you divide it in half, and then you divide each of these in half, and you're going to get a series of trapezoids. It might look something like this. Probably not going to be that drastic. But you're going to get a series of trapezoids. And what you see is that there's an actual curve. As soon as you get this point here, you can pretty well estimate where the curve would be. Okay? If you do this graph to scale, you take a little care and kind of do it right, you see that the curve is going to be like this, and that curve is going to stay very close to these straight yellow lines here that depict the tops of the two trapezoids. Now I'm telling you that the area under the curve itself is going to be the difference in the antiderivative function between this point and this point. And I'm going to send an email, but make sure when you look at this video that you make yourself a note that this antiderivative function should be 100,000, not 100. Okay, I got careless when I typed that, and also I was doing some bad thinking at that time, just some careless arithmetic thinking. Okay, so the whole point then is that once we understand what the curve looks like here, well, we've got a similar curve up here, and we'll have a similar curve down here. We want to compare the trapezoidal approximation to the total area to the actual area under the curve. You're not asked to really construct this one. You're asked to speculate on how it's going to be. You'll see when you read the instructions for the problem.